Hello everybody, in this video we are going to continue our conversation about simplifying expressions using the different laws of exponents. So in all the previous videos we talked about vocabulary, we talked about the zero rule, anything raised to the zero power is zero. We talked about what to do with a negative exponent. All we have to do is move it across the fraction or division line to change the sign. We also talked about the product rule, how to look at our problem, how to organize it, how to combine exponents when you have more than one of the same base, and then how to make sure that our final answer is in the correct form. All right, so we're going to use the power rule, and I want you to look at what the power rule looks like. You have a set of parentheses, you have some stuff inside, but notice that the only thing on the outside of these parentheses is another exponent. So we're taking exponents that are already there and raising them to another exponent. So I'm going to show you how to organize, to set up, organize, and simplify these as well. So one of the things that I want to point out is the difference between what the product rule looks like. The product rule has more things, more than one set of parentheses, and sometimes you don't have a parentheses. Maybe you have a dot that represents multiplication. So you definitely want to look at your problem. But the power rule, you will notice, looks slightly different. You do have a set of parentheses, but you do have an exponent on the outside. So that's what's going to let you know that we are actually multiplying exponents. So for the product rule, you multiply coefficients. For the power rule, you multiply exponents. Okay. So with that being said, let's go ahead and set this up. The first thing I'm going to ask you to do is look inside. Everything inside of your parentheses has to have an exponent. We're going to separate everything, but then we're also going to make sure that everything has an exponent, including the coefficient. So if you look here, we have a -2, an m, an n, and a p. We actually have 4 bases here. So that means we should have 4 exponents. The -2 doesn't have an exponent, so I'm going to give it the understood positive one. The m has a 2. The n does not have an exponent, so give it the 1. The p has a 3. Now, how do we take these exponents and raise them to the third power? Well, just like when we do the distributive property, and we take the number on the outside and multiply them by all the numbers on the inside, that's what we're going to do. We're going to use the distributive property, but just for exponents. So what I'm going to ask is that we take all of our bases, -2, m, n, and p. Just write the bases. The bases will never change when you're doing the power rule. The only thing that's going to change are the exponents. So I'm actually going to draw my arrows here. I'm going to take this 3, and I'm going to multiply it, not by the -2, but by the 1. So we know 1 times 3 is 3. All right, we're going to do the same thing with the m. So I'm going to draw my arrow. 3 times 2, 6. 3 times 1, 3. 3 times 3 is 9. So remember, you're multiplying, you're not adding, you're multiplying. Now, I would tell you we are done here, but when you're doing the power rule, the one thing that I want you to focus on is this coefficient in the front. So I'm going to ask you to put parentheses around this -2, and we can actually take a -2 and raise it to the third power, and it will give us a different number. So we still have to simplify this. So if you grab your calculator, or if you can do this in your head, that's perfectly fine. I'm going to put this in parentheses. Especially when you have a negative base, you're going to put it in parentheses. So notice I have my -2 here. I'm going to use my little arrow right here, and it's going to give me this box so I could raise it to the third power. Once I do this, it's going to tell me that my answer is -8. So our final answer is -8 m to the 6th, n to the 3rd, p to the 9. Now I know this is my final answer because I have one of each kind, 1m, 1n, 1p, no negative exponents, no zero exponents. This is my final answer. Now don't confuse the -8 for something that needs to be dropped, because the -8 is a coefficient. The exponent of the -8 is a positive 1. That lets me know I don't need to move it because the 1 is already positive. So this is my final answer. All right, let's look at this one right here. Notice it's very similar. So the 3 does not have an exponent, so give it a 1. The x has a -2, the y has a 2, the z has a -3. So everything inside the parentheses has an exponent. So we're going to take this 2 on the outside and we're going to multiply. Now before I do, I'm going to write down 3. X, y, and z. And if you want to, go ahead and put parentheses around the 3. Alright, so let's multiply exponents. 2 times 1 is 2. 2 times -2 is -4. 2 times 2 is +4. And 2 times -3 is -6. Now you're going to notice that there's more things to do here to get this to be our final answer. The first thing I'm going to ask you to do is do 2 raised to the 2nd power. You can type it into your calculator, or you can say 3 times 3 is 9. So we have 9 x to the -4, y to the 4th, z to the -6. Now there's another thing that's keeping us from saying that this is our final answer. We have negative exponents. So I know that this is not a fraction, so I'm going to ask you to create a fraction. I'm going to put the 1 over here underneath the 9 because they're both coefficients. And I'm going to separate my x, my y, and my z. Alright, so let's start here. The 9 has a positive 1 as an exponent, so there's no need to move it. This one's good. This one will stay on the top. This is a -4. We can't have negatives, so we have to move it down. This is positive. It's going to stay on the top. This is negative. We're going to move it down. So let's clean it up. 9 stays on the top. Y to the 4th stays on the top. This -4 becomes a positive 4, but on the bottom. This -6 becomes a positive 6 at the bottom. So this is our final answer because we have 1x, 1y, 1z. They're all positive and none of them are zeros. This is my final answer for the power rule. So it's very important that you look at your problem and figure out, is it the product rule or is it the power rule? Because the way we simplify it is different. Alright, with that being said, I'm going to stop right here. I hope these 2 examples have helped kind of simplify these rules, these expressions using the power rule. The next rule that we're going to look at is the quotient rule. So it's a division problem, but we're not doing a whole lot of dividing here. It's all about setting it up, organizing, and simplifying it. So I'll see you in the next videos for the quotient rule.